In the early days of oceanic exploration, sailors whispered tales of great whirlpools, powerful enough to drag entire ships into the abyss. But today, we're not talking about ships, but about something far more immense: carbon dioxide. While the tales of monstrous whirlpools were myths, our oceans possess another kind of power: the power to pull vast amounts of CO2 from the atmosphere. Imagine for a moment, the year is 1958. Charles David Keeling, an American scientist, begins to measure atmospheric CO2 on Mauna Loa, Hawaii. What he discovered was startling: a consistent rise in CO2 levels year after year. Today, this data is represented by the famous Keeling Curve. But as CO2 levels rose, Keeling and other scientists wondered, where does all this CO2 go? The Earth, in its wisdom, has its own system of checks and balances. The forests, plants, and soils absorb a portion of this CO2, but it's our expansive oceans that play the starring role in this carbon capture drama. Covering over 70% of our planet's surface, they absorb a staggering 25% of human-generated CO2 emissions. Let's delve deeper. When carbon dioxide enters the ocean, it doesn't just stay as floating gas bubbles. Through a process known as oceanic carbon uptake, CO2 reacts with seawater, forming carbonic acid. This acid then breaks down into bicarbonate and hydrogen ions. Over time, the depth of the ocean, combined with marine life processes, ensures that this carbon stays submerged, held in the deep for centuries. Now, remember the era of the Titanic? Amidst the sorrow of the tragedy, few recognized the vast beds of microscopic marine plants and animals that carpeted the ocean floors. These are phytoplankton and zooplankton. They absorb carbon dioxide during photosynthesis. Upon death, they sink, forming snowy rainfalls of organic carbon that cascade into the abyss, locking away tons of carbon in the deep ocean layers. Yet, with the intrigue of nature comes a cautionary tale. The ocean's role as a carbon sink has consequences. As more CO2 dissolves in seawater, the water becomes more acidic, endangering marine life, particularly shellfish and corals, which struggle to build their calcium carbonate shells in acidified waters. There's also the story of the North Atlantic in the 1980s, where a sudden and unexpected slowing of CO2 absorption was observed. Scientists were baffled. Investigations revealed a rare occurrence. The ocean had become saturated with CO2 in that region and couldn't absorb anymore. It was a stark reminder of the limits to nature's buffering capacity. So, while our oceans tirelessly work to counteract our carbon emissions, it's clear they shouldn't bear this burden alone. The tale of the ocean carbon sink isn't just about science. It's about balance, responsibility, and ensuring the ocean's own survival. By now, you might be realizing that our blue planet, particularly its vast oceans, does so much more than provide stunning vistas and house incredible marine life. They are Earth's frontline defense against the mounting carbon in our atmosphere. If this insight has awakened a newfound appreciation for our oceans in you, share this knowledge. Spread the word about the silent work of our oceans, and maybe, just maybe, we can tip the balance back in favor of our blue planet. And if you've enjoyed this voyage into the depths of the carbon capturing capabilities of our oceans, do give this video a thumbs up, share with your friends, and consider subscribing for more enlightening journeys into the wonders of our world.